Section 6.3 is solving proportions with cross products. I can solve proportions by using cross products. Every pair of ratios has two cross products. A cross product of two ratios is the product of the numerator of one ratio and the denominator of the other. So if we have the two ratios, 3/5 and 6/10, okay, the cross products are 3 times 10 and 6 times 5. Same thing here. 2 times 11 and 6 times 3. If the ratios are equal, their cross products are also equal. If they're not, the cross products are not the same. What that means, guys, is 3 times 10 is 30 and 5 times 6 is 30. So we know that these form a proportion. We could put an equals in between them. 2/3 and 6/11 we know don't simplify to the same thing. And if we look at their cross products, 22 and 18, those are not equal. So we can't put an equal sign in there and make them a proportion. We can use cross products to tell whether two ratios form a proportion. If the cross products are equal, then the ratios form a proportion. Example 1 here, tell whether the ratios form a proportion. So we're going to check their cross products. Okay, 9 times 34 and 6 times 51. 9 times 34 and 6 times 51. This is 306 and this is 306. So since these are equal, it means we could set these equal and they do form a proportion. Okay, let's check B here. 12 times 50 and 32 times 20. Remember, cross products are one numerator and the other's denominator. So 12 times 50 and 32 times 20. Here we get 600 and here we get 640. These are not equal, so we cannot set them equal. They're not a proportion because if we reduce these down, guys, we wouldn't get the same value. So these are not a proportion. Do they form a proportion? No. Same idea here, number 1. 6 times 7 and 3 times 14. Again, go ahead and pause here if you'd like and try these. 6 times 7 is 42 and 3 times 14 is 42. So since these are equal, we could set our fractions equal. If we reduce this, we'd get 3/7. So yes, these do form a proportion. Same idea here, we're going to check our cross products. So numerator of one times denominator of the other, and numerator of the other times denominator of the first. When we multiply here, we get 280 and 280. Those are the same, so yes, we could make this a proportion. Number 3, 6 times 20, 8 times 11 are cross products. Numerator of one times denominator of the other, numerator of the other times denominator of the first one. We get 120 and 88. Those are not equal, so we cannot set them equal. If we reduce these down, guys, we get 2/5 and 6/11. Those are not the same, so these do not form a proportion. No, they do not. Okay, last one here, number 4. Check our cross products. 15 times 16 and 10 times 24. We get 240 and 240. Those are equal, so we can set our fractions equal to each other. They are proportions. If we reduce them down, we get to the same fraction on both sides. We can use the multiplication property of equality to demonstrate an important property about the cross products of a proportion. So, the cross products of a proportion have to be equal. Because we know that our ratios have to be equal, if we reduce them down, we'd multiply and get the same thing. So 2 times 15 is 30, and 6 times 5 is 30. And we know those have to be equal in order for them to be a proportion. So we can use this property to solve proportions. Human hair grows about 0.7 centimeters in 2 weeks. How long does hair take to grow 14 centimeters? Okay, we're comparing centimeters in weeks. So we want centimeters per week. Again, remember it's important that we keep them the same format. So since we put centimeters first in 2 weeks, in my second ratio, I have to have centimeters. We want to know how long. So we're looking for X weeks in order for it to grow 14 centimeters. And again, I have centimeters on top, weeks on the bottom. I'm also comparing what we know to what we're looking for, or what we're trying to compare. So our ratios work. What's different about this though, guys, versus the ones we've done before, is that we have our variable in the denominator. So 0.7 to 14 is kind of hard to figure out what we had to do there, and we can't use the dividing and then multiplying both sides because we're in the denominator. So we can use cross products here and set them equal to each other. 0.7 times x equals 14 times 2, and we know we can set them equal to because we set it up as a proportion. So 0.7x equals 28 when I multiplied 14 and 2. To get rid of multiplication, guys, we divide. And we get x equals 40. And that's labeled in weeks. So if human hair grows 0.7 centimeters in 2 weeks, it's going to take 40 weeks for it to grow 14 centimeters. Now we are going to use cross products to solve these proportions. 18 times t, and again go ahead and pause here and try these if you want, and then check them. So 18 times t equals 3 times 42. 18t equals 126. We get rid of multiplication by dividing. And again, I got the 126 by multiplying here. And we get t equals 7. Go ahead and try 6. Pause if you'd like. We're going to use cross products here. So in number 5, we could have gone from 3 to 18 by multiplying by 6, or 18 to 3 by dividing by 6, and done the same with 42 to get 7. But in 6, it's harder to go from 10 to 16, and from 45 to a number. So using our first way of mental math isn't very helpful. Our p is in the denominator, so we can't use our multiplying to get rid of the denominator, so we have to use cross products here. 10 times p equals 16 times 45. 10p equals 720 when I multiply those two. Now, to get rid of multiplication, we divide by 10, and p is going to be 72. Same idea here for 7. We're going to use our cross products. So 10 times b equals 9 times 45. 10b equals 405. We get rid of multiplication by dividing. Remember, we always move away from our variable. And b is going to be 40.5. And it's okay to have decimals. Last one here, cross products. 0.4 times z equals 18 times 6. 0.4z equals, when we take 18 times 6, we get 108. We get rid of that multiplication by dividing by 0.4. And z is going to be 270. If you want to check these, go ahead and type in your calculator 0.4 divided by 6, and you'll get 0.06 repeating. Then take 18 divided by 270, and we got the same thing, 0.06 repeating. So that's one way to check and see if your proportions are right. Okay, last thing here in section 6.3 is just a summary of the methods we've used for solving a proportion. We used equivalent ratios, where we looked and saw, can we go from our complete fraction to our incomplete fraction by multiplying by a number or dividing by a number. Then we used algebra, where our variable was in the numerator, and it was being divided, so to get rid of division, we multiplied both sides by our denominator. And then the last way here is with cross products. And that's all for section 6.3.